Hello. At this video, I will be introducing the concept of equipotential lines briefly. We can represent electric potentials, in other words voltages, pictorially. Let's assume that we have an isolated positive point charge and its electric field lines like that. Electric field lines radiate out from a positive charge and terminate on negative charges. So let me draw here a negative charge. Yes. Here I use black arrows to represent the magnitude and direction of the electric field lines. And I use red circles like that. These places where the electric potential is constant. These are called, equipotential lines. The potential for a point charge is the same anywhere on an imaginary sphere of radius r surrounding this charge. Since the potential for a point charge is given by V equals K Q over R and thus has the same value at any point that's a given distance r from the charge. So in addition to this, since the electric field lines point radially away from the charge, they are perpendicular to the equipotential lines. Yes, like that. Let's make the measurement. Before the measurement, I should notice that we use a millimetric graph paper to illustrate the both electric field and equipotential lines. Due to these 2 points show us the positive and negative point charges, we will observe and measure the voltages at any points between them. For example, we apply 5 volts across these points. When I measure the voltage between them, let me put this voltmeter here and just connect the probes. We see that voltmeter shows us approximately 5 volts. So it works. Now let's say this is A point, B point, C, D, E and F points. These points are also illustrated on the graph paper here. A, B, C, D, E and F. Also the point charges illustrated. Then we will put the probe on the point A and we see a value of voltage. Then we will try to find a different location which shows the same voltage as that of point A. When I find it by looking at the voltmeter, I will point out it on the graph paper and repeat the same procedure for other points and record the coordinates. After you watch this video, you will draw these lines by yourself with the data we sent to you. Let me show you an example. Here, I put the positive probe of the voltmeter on the reference point, the positive charge, positive point charge. Then I put the negative terminal of the voltmeter on the point A. This is point A, so here, point A. Then we will observe a voltage value. Okay? Here also another voltage. If I keep going on to the negative point charge, as you see, the voltage value is increasing. Okay? So, on carbon paper, at any location I put the probe, the voltage value will differ. So, if I have a voltage value for point A as 3.7, let's say, I will find another location that shows the same voltage value. For example, here. And then another location, for example, here. Okay, so moving the probe, we will try to determine two different points shows the same potential difference as the point A. And we will indicate these points on the graph paper. Then we will have approximately 5 points, and then we will make a connection. I mean, we will draw a line, or we will draw a curve connecting them. So these lines will be the equipotential lines for this experiment. Then we will draw electric field lines which is perpendicular to the equipotential line. That's all. Thank you for watching.